Hello, cosmic explorers! Today, we'll journey into one of the most profound mysteries of the universe: what happens when space and time collide. We experience space as the physical dimensions around us and time as the steady march forward. But in the realm of physics, these concepts are far more intertwined and dynamic. Together, they form the fabric of reality, space-time, a continuum that shapes the universe. But what happens when this fabric is bent, twisted, or pushed to its limits? Let's dive in and explore. Before we dive into collisions, let's define space and time. Traditionally, space is seen as the three-dimensional area where objects exist and move, while time is the one-directional flow in which events unfold. But Albert Einstein's theory of relativity transformed these ideas forever. Einstein revealed that space and time aren't separate entities, they're part of a unified four-dimensional structure called spacetime. In this framework, the three dimensions of space and one of time interact constantly. For example, the gravity of a massive object, like the Sun, bends spacetime, influencing how planets orbit. The more mass an object has, the more it warps the surrounding spacetime. Picture spacetime as a rubber sheet. Place a heavy ball, like a star, on it, and the sheet bends. Smaller balls, like planets, roll along these curves, creating orbits. This bending isn't limited to space, it affects time as well. This phenomenon is called gravitational time dilation. The closer you are to a massive object, the slower time flows compared to someone farther away. For example, an astronaut orbiting near a black hole would experience time more slowly than someone on Earth. This dynamic interaction of space and time becomes even more extreme in environments like black holes. Black holes are regions of space where gravity is so intense that not even light can escape. They represent the most extreme collision of space and time. At their center lies the singularity, a point of infinite density where the laws of physics as we know them break down. As you approach a black hole's event horizon, the boundary beyond which nothing can escape, space and time behave in bizarre ways. From an outside perspective, time appears to slow down for anything nearing the event horizon. But for the object falling in, time would seem to flow normally. Inside the event horizon, space and time essentially swap roles. Time moves inexorably forward, like a one-way street, while space becomes twisted and compressed. The collision of space and time isn't just something that happens in black holes, it's also central to the origin of the universe. At the moment of the Big Bang, space-time itself came into existence. Before the Big Bang, we have no concept of space or time, everything was compressed into a singularity. As the universe expanded, space stretched, and time began its continuous forward flow. Even today, the universe continues to expand, with spacetime itself stretching across vast distances. The connection between space and time opens the door to tantalizing possibilities, including time travel. If spacetime can be bent or warped, could we manipulate it to travel to the past or future? One theoretical concept is the wormhole, a shortcut through spacetime connecting two distant points. In theory, a stable wormhole could allow for near-instantaneous travel across the universe, or even enable time travel. However, stabilizing a wormhole would require exotic matter with negative energy, something we've yet to discover. Even if time travel were possible, it would bring paradoxes, like the famous grandfather paradox: what happens if you travel back in time and prevent your own existence? These questions highlight the complexities of manipulating spacetime. In recent years, scientists have observed gravitational waves, ripples in spacetime caused by cataclysmic events like the collision of black holes. Detected for the first time in 2015 by the LIGO Observatory, gravitational waves confirm Einstein's predictions about the dynamic nature of spacetime. These ripples allow us to hear the universe in a new way, providing insights into extreme cosmic events and helping us understand how spacetime reacts to massive disturbances. So, what happens when space and time collide? They don't simply crash, they blend, warp, and evolve together, shaping the universe we live in. From the bending of light around stars to the extreme environments of black holes, space and time are in constant interplay. These interactions give rise to phenomena like time dilation, the expansion of the universe, and the tantalizing possibilities of time travel. As we continue exploring, we'll uncover even more secrets about this mysterious fabric of reality. Thanks for joining me on this cosmic adventure. Don't forget to like, share, and comment with your thoughts on space-time. Until next time, keep looking up.